Okay, welcome to today's video. So we have a graphing question here. So I thought to say graph y equal to sine x minus 2 like this. Okay, so when you look at this function that you have here, you notice to say that the amplitude it's 1 and the period there is 360 divided by the constant in front of the angle here, which is just the 1, so we just get a 360 there. So then the first shift that we have a vertical shift of 2 units down, so because of the negative that we have there. Okay, so then now that we have that information, let's get to graphing then. Okay, so here this is our 0 there, 90, 180 degrees, 270 and 360 there. So a normal sine graph has a maximum peak value in 1 there, and we have a negative 1 down there. So then it's going to go this way, touch 1 at 90, back to 0 at 180, touch negative 1 at 270, and back to 360 there at 0. So now, since there is a shift that is happening here in the y-axis, so we're going to drop the 0 line 2 units down there. So when we drop the 0 line, we bring it to negative 2 there. Okay, so now since this becomes the new 0 line there, so then we check to say the maximum amplitude of this graph is 1, so negative 2 there plus 1, we get a negative 1, negative 2 minus 1, we get a negative 3 here. So then the graph will now be like this. It will touch negative 1 at 90, touch 2 there at 180, negative 3 at 270 there, and negative 2 at 360 there. So the nature of this graph is going to be like this. Like that. So this is the graph of y equal to sine x minus 2 like this. This is the graph of y equal to sine x like this. Okay, so the next graphing question that we're going to look at is y is equal to sine open brackets x minus pi over 6 there. Okay, so first things first, we need to determine the amplitude of this graph and the period there in the first shift. So our amplitude is 1, our period is 360 degrees, and the first shift so let me just do this. So the first shift is equal to pi over 6. So this pi over 6 is a leading angle. Okay, so now since our amplitude is 1 here and